Today we're going to go over how to rationalize the denominator. First, before we talk about the actual rationalization, we have to understand what a square root does. So if you're given this problem, square root 9 times square root 9, what is the outcome? Now, I believe a lot of people would be inclined to take the square root directly. So square root of 9 is 3 times square root of 9, which is also 3. And when we multiply these two values, we get 9. But now what do we notice? We notice that square root 9 times square root 9 is equal to 9. If we do the same thing for square root 16 times square root 16, square root of 16 is 4, and 4 times 4 is equal to 16. Now we're noticing an interesting pattern here. That is, the square root of a number times the square root of the same number is just equal to the number itself. This is an important rule that we're going to use to rationalize the denominator. Okay, now on to our first example of how to rationalize the denominator. First of all, let's identify what the denominator actually is. So, as we notice, the denominator is this expression here at the bottom, 2 square root 7. And what does rationalizing mean? Rationalizing means that we want to get rid of this radical here, this square root 7. So, as we mentioned before, to get rid of this square root, we can multiply it by itself. So do square root 7 times square root 7, and as we explained previously, that'll just give the number inside of the square root itself. So, to do this, we must multiply by square root 7 in the denominator. But if we're doing something in the denominator, to not change the actual value of this expression, we need to repeat this in the numerator as well. Next, we remember that we multiply numerators with numerators and denominators with denominators. We then obtain 3 square root 7 over 2 square root 7 times square root 7. Now there's not much we can do in the numerator, so that stays the same. But then, as we mentioned before, we have this square root 7 times square root 7, and that'll just give us 7. So we get 2 times 7, and our final expression is 3 square root 7 over 14. Now let's move on to something a little bit more complex. Here in the denominator, instead of having a single expression as we did last time, we have two distinct values here. We have root 6 plus 2. Now here, we can expect to multiply just by root 6 and be able to get rid of this radical term. What we must do instead is multiply by root 6 minus 2. So essentially, we're multiplying by the same thing here, by these same values, except we are switching the sign here. That being said, if this sign here had been negative, this sign here would be positive. But because the sign is positive, it will become negative here. The same applies for before in terms of repeating the operations in both the numerator and the denominator. Now, let's distribute. We get square root 3 times square root 6. That becomes square root 3 times square root 6. Next, we get square root 3 times negative 2. So we get negative 2 square root 3 over, we do the distribution again, square root 6 times square root 6. We obtain 6, but for the sake of writing everything out, I'll just write that. Next, we do square root 6 times negative 2. We get negative 2 square root 6. Next, we move on to the 2. We do 2 times square root 6. We obtain plus 2 square root 6. And lastly, we do positive 2 times negative 2. And with that, we obtain negative 4. All right, so now what do we notice here? We notice that these two terms in the middle will cancel out because we have negative 2 square root 6 plus 2 square root 6. These will cancel out. What else do we notice? We notice the root 6 times root 6. And we remember that this is just equal to 6. Next, if we look at the top, we have square root 3 times square root 6. Another way to rewrite this is square root 3 times 6, or square root of 18. Writing that all out, we get square root 18 minus 2 square root 3 over 6 minus 4. We then get square root 18 minus 2 square root 3 over 2. Now I won't go into how exactly we can simplify this further. That will be a topic of another video. But we effectively remove the radical from the denominator, which is what the question asked.